just to kind of take you back a little bit in time, when optical gas imaging first got started, about 20 years ago, there was a gentleman that had contacted me about the use of thermal imaging cameras to actually be able to detect a gas plume or a gas cloud. The reason for that was he actually had a family member who was killed in an accident when a gas cloud actually essentially ignited, and his family member was involved or a part of that. So he started to seek out basically a way to see if there was any way that that could be avoided in the future, and was kind of on a mission. So with that, his original idea for using an infrared camera was that based on the fact that it provided an image and it provided non-contact temperature measurement, and thinking that the gas, the different types of gases would be cool or cold, that you would be able to image that just based on kind of temperature or energy differences. But I, quickly explained to him that, that was not the case. And interestingly enough, for the 15 years prior to that, I'd done lots of demonstrations of infrared cameras in refineries and petrochemical plants, mainly looking at pipe racks that were had aluminum sheeting or aluminum wrap around it that are insulated pipes. And they were often looking for the same kind of problem, where they may have a pinhole leak around a weld seam, and their thinking is that by conduction, basically, that it would create a cold spot on the metal sheathing, which in this case was usually aluminum. But just about impossible to do because of low emissivity conditions that exist on that. And the leaks would often get dissipated underneath the insulation. So it was really just kind of a lost cause. So anyway, when he asked me about this, we were actually at the time working on another project with the Air Force, and we were actually imaging the combustion of jet engine fuels, basically on fighter jet aircraft. It was used for target signature analysis. And in doing that, we actually started working with these narrow bandpass cold filters. So I mentioned this to him and said, I think maybe this is more of the way to do this, so that we can line up the absorption bands of the different gases that you want to be able to detect. And maybe we would then be able to visualize those, but we really weren't sure how to do it. So what we proposed and what we ended up doing was providing what's called a pore-filled liquid nitrogen cooled camera. So it has a dewar, you pour liquid nitrogen into it, you put a detector in the bottom of it, basically gets to cryogenic temperatures. You put a lens on that, and what we did is we basically got a whole bunch of narrow bandpass cold filters where we looked at the various gases and said, okay, we think a peak is about here, so we'll narrow that filter down to this kind of region of wavelength, and maybe you'd have some chance of being able to see it. So we packaged all of that up, sent them to this gentleman who's here in Texas as well. He got the system and did some testing, and he literally took the filters that we provided, these little 1-inch diameter filters, very thin, and taped them onto the front of the lens. And he called us about 2 weeks later and said he had no luck trying to see propane or methane or butane or ethane, any of those. And he said, hey, but one thing I did kind of notice, I took those filters and I put them on the back of the lens, and I noticed that the image got a little bit better. It seemed to be more sensitive. And he said, hey, could we do anything to increase the sensitivity? So we did that, and he came out to California, and in Santa Barbara, we set up the system out in a parking lot behind our offices, put a propane bottle out there, and cooled down the sensor, and turned on the monitor and made some adjustments, and then lo and behold, we saw gas. And this was literally 20 years ago. And it was the first field operational OGI camera. There were some people who had written some papers about maybe doing it, but nobody had actually did it. And we were the first team to actually make it happen. It was probably, in my 35 years, I would say one of the most magical moments of just kind of like, wow, this is pretty incredible. And, you know, we saw immediately what the potential probably was going to be for the technology.